Welcome to the fog.
Hi guys. Welcome to my channel. In today's video, I wanted to assemble the stopwatch with the feature of display on LCD. The device is based on a microcontroller AVR ATMega328P. Also, I am using LCD Nokia as a device display. The device has a button that starts, pauses, and restarts the stopwatch. I am going to use a built-in timer of the microcontroller for stopwatch implementation. AVR timer is very accurate, precise, and reliable. It is totally independent of the processor. Thus, it runs parallel to the processor and there is no processor intervention, which makes the timer quite accurate. The stopwatch includes the following base electronic elements. Microcontroller AVR ATMega328P. The device uses the following peripheral features of the microcontroller. 16-bit timer counter interrupt for counting of time. Master-slave SPI serial interface for connecting the display to a stopwatch. Monochrome graphic display Nokia 5110 with internal controller driver PCD8544. It consists of 6 rows from Y address 0 to Y address 5 and 84 columns from X address 0 to X address 83. If a user wants to access the position of displaying the result on LCD display, must refer to the relationship between X address and Y address. Data that will be sent to display is 8-bit and it will be arranged as a vertical line. In this case, bit MSB will be lower and bit LSB will be upper as shown in the picture. The button is needed to switch the device operating modes such as start, pause, and restart. To create the stopwatch I have developed a circuit diagram that looks like this. It's time for us wrote code to reinvigorate the microcontroller. My explanation of the code will not be detailed, and if you have any questions, please leave them in the comments. Okay. Let's start. Launch Atmel Studio. Click New Project to start the new project generation wizard. This dialog provides the option to specify the programming language and project template to be used. The project will use C. So make sure C++ is selected in the upper left corner. Select the C executable project option from the template list to generate a bare-bones executable project. Give the project a name and click OK. Next, it is necessary to specify which device the project will be developed for. The project will be developed for the AVR ATMega328P microcontroller. Select entry in the device list and confirm the device selection by clicking OK. Type the code of a program in the main source editor area of Atmel Studio. Tell the compiler at what speed our chip is running so that it can calculate delays properly. Next, include the preamble, which is where we put our include information from other files, which defines global variables and functions, header to enable data flow control over pins, header to enable interrupt function in the program, and header to enable delay function in the program. Defines pins of the chip I/O ports for the LCD display connecting via serial peripheral interface. Defines pin of the chip I/O port for display reset. Defines pin of the chip I/O port for display mode selection. Defines pin of the chip I/O port for button switch connecting to a microcontroller. The debounce time needs to be adjusted to the time it takes the switch to go from a digital high to a digital low after all the bouncing. The bounce behavior will differ from a switch to switch, but 20-30 milliseconds is typically quite sufficient. Defines the duration of a button press to stopwatch reset. Initialization of the hex code array of separator character on the display. And initialize the hex code array of numeral character on the display. Declaring the variables for timing. Declaration the variable for the timing of a button press duration. The procedure to microcontroller ports initialization. Set up port B as the serial peripheral interface for display connecting. Set up the pin 0 of port C as input for connecting the button switch. The procedure to serial peripheral interface initialization. The next two procedures turn the display on and off. The function to transfer data to the serial peripheral interface for displaying to LCD. The procedure to reset the display. The function to transfer command data to the serial peripheral interface for display control. The procedure to display initialization. The procedure to clear display. The display clearing procedure will be transfer zeros to the address area of the display matrix. The procedure sets the current position of the pointer at the matrix of the display to x and y coordinates. The procedure transfers hex codes of the numeral character to the display. The procedure transfers hex codes of the separator character to the display. The function returns a Boolean value indicating whether or not the button was pressed. The procedure set up the prescaler chip timer to 256 and turn on the mode by clear timer on compare. Counter initialize. Set output compare register to 625, so corresponds to 10 milliseconds of timer. Enabling output compare match interrupt enable bits. It ensures that an interrupt is fired whenever a match occurs. In the AVRs, there's only one single bit that handles all the interrupts. Thus, to enable it, we need to enable the global interrupts. This is done by calling a function named s. Whenever a match occurs, timer counter becomes equal to output compare register, and interrupt is fired. Now since an interrupt is fired, we need an interrupt service routine to attend to the interrupt. The interrupt is fired regularly every 10 milliseconds. Here stopwatch counter increased at 10 milliseconds, also if the button is pressed then performed pause the timer counter, and if the duration of the button is press over 1 second then performed reset the timer. the function to display the zero value of the stopwatch. The main function is where the AVR starts executing your code when the power first goes on, so it's the entry point of the program. This is where the initialization functions for ports, interfaces, peripherals, and display launching. This statement is a loop, often referred to as the main loop or event loop. This code is always true, therefore, it executes over and over again in an infinite loop. The main code displaying the stopwatch value on the LCD is executed in the loop. During debugging of the code, errors were found that need to be fixed. First, specify the return type of the procedure as void. Correctly specify the bit shifting operator. And last, fix the determination of the number of digits in a millisecond counter. The next step is building the project. It means compiling and finally linking all object files to generate the executable file hex file. This hex file is generated inside the folder debug, which is inside the project folder. The hex file is ready to be loaded into the microcontroller chip. I burn the program into the memory of the ATMega328P microcontroller using a Verdude software and an ISP programmer. Okay. Now, the microcontroller works in accordance with the instructions of the program. Let's check it out. You can help me by sharing this video if you like it. Please like, comment and subscribe. Thank you for watching. See you later.